The sine function. Let's consider the unit circle given by u squared plus v squared equals 1. Now let x be the standard arc measure in radians from 1, 0 to uv as shown. Let's focus our attention on the second coordinate v equals sine x as x makes one counterclockwise lap around the circle, i.e. x is between 0 and 2 pi. So v equals sine x, this coordinate right there. For what values of x does sine x equal 0? What about when sine x equals positive or negative 1? There are two positions on the unit circle where the second coordinate is 0, but there are three solutions for x being between 0 and 2 pi, including 0 and 2 pi. Recall, sine 0 equals 0, so here's 1 point. Sine pi equals 0, so over here. Sine 2 pi equals 0, so once you go all the way around the circle and back to this point, now you're at 2 pi, and that sine of 2 pi is also 0. Sine of pi over 2 up here is 1, and sine of 3 pi over 2 is negative 1. Find values of sine x for the arcs that measure x, where x is greater than or equal to 0 and less than or equal to pi over 2. Remember, pi over 2 is 90 degrees. So our maximum sine value is at 90 degrees, and that is a value of 1. So sine of pi over 2 is 1, and you can measure the sine value by the length of these lines. So here we have 5 pi over 12. That is a sine value of 0.966, which is very close to 1. As you get down to pi over 4, we have 0.707. At pi over 6, we have 1/2. So here is where sine of pi over 6 is 1/2. As you go down to 0, though, then there's no more line. Sine of 0 is 0. The value of sine x rises quickly as x increases from 0, and then more slowly as x approaches pi over 2. What do you think will happen if x increases beyond pi over 2, terminating at points in the second quadrant? Discuss. Take a moment to draw more points to determine sine values in second quadrant. For consistency, use pi over 12 increments. We'll show the results on the next slide. The symmetry of the unit circle allows us to evaluate sine x for values of x in the second quadrant based on first quadrant values. So if you just take a point here and draw a horizontal line across to the second quadrant, this point will have the same sine value as this point. On the next slide, we'll see the results in a table. Here are all of the values of these sines. So sine of pi over 12 is 0.259, which is the same value of sine of 11 pi over 12. So these are the same. And you can see that pi over 6 has a sine value of 0.5, and so does 5 pi over 6. So they have the same sine values. So as you move up the circle, you will see that the sine values increase and then decrease like so. Let's see the consequences of symmetry in quadrants 3 and 4. Go to the next slide. The values of sine x are now reflected about the x-axis. Since the points are below the x-axis, the values of sine x are negative in quadrants 3 and 4.